Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. Welcome to the world of real-time data solutions. In this video, we're diving into Azure Event Hubs, the powerhouse of streaming data and event ingestion. Why is this exciting? Because in our data-driven world, being able to process and analyze data in real time is key. Imagine you're running a popular online retail store. On big sale days, your website traffic spikes and orders pour in by the second. Traditional data processing methods might not be able to keep up, causing delays in order processing, inventory updates, and even potential loss of sales. Enter Azure Event Hubs. With its ability to ingest millions of events per second, you can track every click, every order, every cart update in real time. This means your inventory always stays up to date. Your customers get instant order confirmations and you get real-time insights into your sales trends. In this video, we will explore how Azure Event Hubs can transform your business operations, making them more efficient, responsive, and informed. I will describe the benefits of using Event Hubs and how it captures streaming data, and explain how to process events. We will also look at how to perform common operations with the Event Hubs client library. Azure Event Hubs is a platform and service for big data streaming and event intake. It can handle and process millions of events every second, which lets you examine your data as soon as it comes in and act on business needs right away. With Event Hubs, businesses can collect and store streaming data and use it to improve their understanding, analysis, and actions based on real-time events, increasing their productivity and customer satisfaction. Event Hubs is a fully managed service that requires minimal setup or maintenance. It offers a consistent event streaming platform with a buffer that keeps events for a period of time. We use it to decouple event producers from event consumers. Scaling options such as auto-inflate adjust the number of throughput units to suit your business needs. Azure Event Hubs is an event streaming engine that can handle AMQP, the Advanced Message Queuing Protocol, Apache Kafka, and HTTPS protocols. It lets you run Kafka workloads on Azure Event Hubs without changing any code. The ecosystem also lets you integrate easily with Azure Functions, Azure Spring Apps, and other data analytics platforms and technologies such as Apache Spark and Apache Flink. Event Hub uses a partition consumer model, enabling multiple applications to process the stream concurrently and letting you control the speed of processing. The image on the slide shows you key components of Event Hub's architecture. On the whiteboard, I will now zoom into this picture and explain the different components in detail. So let's zoom into these Event Hub's key components a bit. Producer applications can send data to an Event Hub using Event Hub's SDKs or any Kafka producer client. A namespace is the management container for one or more Event Hubs or Kafka topics. The management tasks such as allocating streaming capacity, configuring network security, enabling disaster recovery, etc. are done at the namespace level. In Event Hubs, you can group events into an Event Hub or a Kafka topic. It's an append-only distributed log, which can have one or more partitions. Partitions are used to scale an Event Hub. They are like lanes in a highway. If you need more streaming throughput, you need to add more partitions. Consumer applications consume data by seeking through the event log and maintaining consumer offset. Consumers can be Kafka consumer clients or Event Hubs SDK clients. Consumer group is a logical group of consumer instances that reads data from an Event Hub or Kafka topic. It allows multiple consumers to read the same streaming data in an Event Hub independently at their own speed and with their own offsets. Let's look into scaling for a moment. When you create an Event Hub's namespace, you configure the number of throughput units, TUs, you want. A single throughput unit lets you use up to 1 megabyte per second or 1000 events per second, whichever comes first for ingress, and for egress up to 2 megabyte per second or 4096 events per second. You require 3 times that amount of output, then configure 3 TUs. You can change the number of TUs after creation too, in case it becomes necessary. The number of partitions used in a single Event Hub has an effect on performance too. At the creation time, you need to set a number of partitions, and only in the premium and dedicated tier you can change that afterwards. Partitioning is a way of organizing data that lets you publish and consume data in parallel. To scale effectively, we suggest that you balance scaling units and partitions. Generally, we advise a maximum throughput of 1 megabyte per second for each partition. So a guideline for estimating the number of partitions would be to divide the maximum anticipated throughput by 1 megabyte per second. Azure Event Hubs enables you to automatically capture the streaming data in an Azure Blob Storage or Azure Data Lake Storage account of your choice. Event Hubs Capture enables you to process real-time and batch-based pipelines on the same stream. It enables you to set up a window to control capturing. Each partition captures independently and writes a completed block blob at the time of capture, named for the time at which the capture interval was encountered. You might be concerned about capture impacting your throughput, but there's no need. Event Hubs Capture copies data right from the internal Event Hub storage, avoiding using up your egress quotas for throughput units and leaving your egress for other processing readers. You can increase the capacity of your event processing application by having more than one instance of the application and having it distribute the work among them. The main concept for scaling with Event Hubs is partition consumers. Unlike the competing consumers pattern, the partition consumer pattern allows high scale by eliminating the contention, bottleneck, and enabling parallelism from start to finish. For example, imagine a home security company that watches over 100,000 homes. Every minute, it receives data from different sensors, like motion detector, door window open sensor, a glass break detector, and so on. And these all are installed in each home. The company offers a website for residents to check the activity of their home almost instantly. Each sensor sends data to an Event Hub. The Event Hub has 16 partitions in this example, and on the customer side, you need a way to read these events, combine them, and put the aggregate in a storage blob, which is then displayed on a user-friendly web page. The consumer in a distributed environment needs to handle these requirements. Scale, have multiple consumers, each one responsible for reading from some Event Hubs partitions. Load balance, adjust the number of consumers as needed. For example, when more events are coming from a new sensor type, for example, a carbon monoxide detector in each home, the operator, a human, can add more consumers. Then the group of consumers can redistribute the partitions they read from to share the load with the new consumers. Seamless resume on failures. If consumer A stops working, for example, the virtual machine that runs the consumer suddenly shuts down, then other consumers can take over the partitions that consumer A was reading from and keep going. Also, the point where they continue, called a checkpoint or offset, should be exactly where consumer A stopped, or slightly before that even. Consume events. Besides the previous 3 points that deal with the management of the consumer, there must be code to process the events and do something useful with them. For example, aggregate them and upload them to blob storage. There's no need to create your own solution to fulfill these requirements. The Azure Event Hubs SDKs offer this functionality. In .NET or Java SDKs, you can use an event processor client, the event processor client as it is called in the methods, and in Python and JavaScript SDK, you can use the Event Hub consumer client. We suggest that you use the event processor client for most scenarios where you need to read and process events. Event processor clients can cooperate with a consumer group for an event hub. Clients will automatically handle the allocation and balance of work as instances join or leave the group. This is achieved by the mechanisms shown on this slide. Partition ownership tracking. This is a mechanism that allows event processors to distribute and balance the work of reading from Event Hub partitions among themselves. Each processor claims ownership of some partitions by updating a checkpoint store and communicates with other processors to adjust the load. Checkpointing. This is the process that marks the position of the last successful processed event within a partition. It helps to resume processing from the same point or slightly before in case of failures or disconnections. It also marks events as complete by downstream applications. Receive messages. This is the function that processes the events delivered by the event pump. It handles one event at a time from a specific partition. It should be fast and have retry logic to avoid missing or duplicated events. It can also use two consumer groups for different purposes. Thread safety and processor instances. By default, the function that processes the events is called sequentially for a given partition, while events from different partitions can be processed concurrently. Any shared state that is accessed across partitions have to be synchronized. Every Event Hub request from a producer or consumer client needs authorization. This way, the service can check if the client has the necessary permission to send or receive the data. Azure Event Hubs offers the following options for authorizing access to secure resources. Microsoft Entra ID integration with Event Hubs resources provides Azure role-based access control for fine-grained control over a client's access to resources. You can use Azure RBAC to grant permissions to security principal, which may be a user, a group, an application service principal, or a managed identity. The Azure built-in roles are listed on the slide. You have the Azure Event Hubs data owner. You can use this role to give complete access to Event Hubs resources. The Azure Event Hubs data sender is of course only used to give send access to Event Hubs resources. And we have a receiver role as well, which you can only use or use only to give receiving access to Event Hubs resources. Microsoft Entra ID authenticates the security principal and returns an OAuth 2.0 token. The token can be used to authorize a request to access an Event Hubs resource. In your code project, you can request an OAuth 2.0 access token from Microsoft Identity Platform with the Microsoft Authentication Library, the MCEL. For Event Hubs resources, you can use Shared Access Signatures, the SAS, to give limited access to others when you cannot use Microsoft Entra ID. The signatures can have restrictions on how long they are valid or what permissions they allow, which helps you control your resources better. You can use SAS to grant access to publishers or consumers. Both works. But as best practice, we should use Enter ID integration whenever possible. Let's have a look at how we can send and receive events with the Event Hubs client library. In this video, I will show you how you can use the Event Hubs client library to send and receive events to an Event Hub. So what we're looking at here right now is in the Azure portal an Event Hubs namespace. The namespace is sort of an account or a big container that entails multiple event hubs. If you want to, it can only just, like in my case, include one, but we can have multiple event hubs in one event hubs namespace. The namespace itself provides us with an endpoint under that domain servicebus.windows.net by the name of this. So this is where we are connecting to. Now, I want to show you a couple of things here. So this host name is important. We will need this in code. And then, of course, we need to have access to this. And since this is like a very common theme, we will use connection strings using access keys for this. We'll find those in the settings area here under shared access policies. And here's a default one that I did not create. You can create your own one that would allow you to also distinguish between is whatever uses this key or this access policy, should it manage the event space, pretty much do everything with it, change configuration, send and receive, or should we just send or listen? You can set this up in the way you want. With this root manage shared access keys, that can obviously do all of these. And then you get a primary key, secondary key, and also the connection strings for those. The connection string that I have in here, I will use this. And this time I will use it right. So you will see what I mean by this. At that point also, you can go ahead and regenerate them in case they were exposed, or you just want to regularly generate new ones, just in case. Now, another important topic, as I said, so we are not going to send events to the Event Hubs namespace. We use the host name, but then we need to reference an Event Hubs. I have one in here right now. That's the Event Hubs MKE 5827. This is an active Event Hub that I have right now. So this is the actual Event Hubs instance. So this is where the data will be sent to. And of course, to send it to some Event Hubs, we need to have a consumer group. Now, I didn't create an additional consumer group. I just have the default one. That is one that is always created when you set up a new Event Hubs, so you can use this. But of course, you can have exactly the same thing like we said before. You can have consumer group for all the orders or for all the payments or whatever you would like to use to organize certain events that belong from a logical standpoint together. So, but I will just use the default one. Now, I will do this in Visual Studio Code where I send data to this Event Hubs now. And let me explain what I have here. So I have two different little applications. One is the Event Hub sender. So we start with this. The other one is a receiver then, obviously. So what I meant before, first of all, we need to have the Azure Messaging Event Hubs library. And specifically for this one, I will use the producer library. So because this is only used to send, to produce events and send them to the Event Hubs. What I need then to set up is I need to have the Event Hub name. That is not the name of the namespace. That is the name of the Event Hub. And how do I get, or how does the code know where to find that event space, right? So this is Event Hub space. And I used the connection string for this. And when I said this time I did it right, remember, like I said you now multiple times to you, please don't put your secrets into code. And now that we have introduced Azure Key Vault, I wanted to show you how you could do this properly. So if you look down here, usually I would use the producer client and instantiate this with the connection string. So where does it get the connection string from? In this example, I use a Key Vault where I get access to with a user assigned managed identity. This user assigned managed identity is referenced here with this ID. That's the ID of the user assigned managed identity. And I have created an access to the key vault for this user assigned client identity. So what happens here, we use this KV, the key vault client, to get a token here using the managed identity, and I will store this and then retrieve using this key vault client. I will get the secret, what I used here to store this very long name, but in this secret I have the connection string that I just showed you in the portal that comes from this root shared key. So this is stored in a key vault, and I retrieve this safely in here, so I don't have any secrets. That's just one way of doing this, right? So I just wanted to show you this at least once so that you know how you can do this in a proper way. So yeah, we get the name of the hub, we have the connection string, and that is now enough for us. Now we will go and create such a producer client that we use then to send the events. The producer client can only send events, cannot receive it. What we do locally is we will create a batch out of 3 different messages. There are different sending ways you can do this in batch. You can do distinct events too. So batch makes it's a good choice if you have to send more than just a single, let's say more just a single, or just a few more that you want to send. So I will create events that are just named first event, second, third, and so on. Then we will send this asynchronously, and once this is done, we will see that these 3 events has been published, hopefully. So if that works okay. So, and then on the other side, I will just show you this first, and then we can go through this. So the receiver app is using a similar approach when we talk about the library. So we see the messaging event hubs in here, and now this time we have the processor, because we want not only to get them, but we also want to consume them. So we have those different libraries, consumer and processor, added. And I use again the key vault library, which I haven't talked about in the sender option here. So this is the library that we need to use for getting something from key vault, and the identity is here to get us the methods that we can leverage our user assigned message identity. Now it's a user assigned managed identity, not a message identity. In this case it is, but you know what I mean. So this is now the receiver. Similar option, but this time we introduce a so-called checkpoint store, and we use a blob container for this. Other than this, it's the same thing. So we access using the connection string. We get this from key vault. We also have an access key now connection string to that blob storage, because we need this to, the checkpoint store in general is it's a durable store where the code can then use this to store the state of the event processor and maintain it throughout the life cycle. And this allows for resiliency in the face of something going wrong, a failure, and the processor can start from where it left off, rather than processing events that it already has handled and starting all over again. So this is the idea. So it will use that blob container to store state while it is receiving this information, these events from the event hubs. So we instantiate an event hub consumer client. We access the default consumer group. So we get access to this $default consumer group I showed you in the portal. Then we set up a connection to the storage, to the blob container. We use the blob container client for this one. We're using the connection string. Then the event processor client will instantiate it using that checkpoint store in here with the consumer group that we access. And then also, let me just change this real quick so you can see the full lines in here. So we use storage client, the checkpoint, the consumer group, we have the connection string, and we give it the name of the event hub. And then we use this to store them or to register these handlers for processing events and handling errors inside. And then we start processing asynchronously with the time span in between of 30 seconds, just to make sure that everything works okay. And here's an implementation also on how to process the events. Basically, we will always say, yeah, we're going to receive this, then we update the checkpoint, and in case something goes wrong, we also get an exception here. So there's a lot more than we actually use, but it's a good point of saying, yeah, we need some logic around this and make this work okay. So now let's switch to the terminal, and this is the sender one. So I will just run this application now that we have everything in place. So a batch of 3 events has been published. What we should see now on the side in Azure is that I mean, I did this a few times before, but you can see that yeah, there are some spikes. I don't think that we actually see the messages that are coming in already. So it will take some time for this to be updated. So I will expect to see a third spike in here because I did this twice before and the time is a little bit off. So I think we don't see this already in here, but that is not the important piece because this is not real-time data. So the important part will be if it says was published, then I should be able to receive these messages in here right now with the receiver app. So let's see. What we're doing here with this application now, we're reading from the default consumer group where those messages are stored. And now this application says, hey, I want these events that we have currently in the consumer group default, and then print them out. And we should see here coming back the first, second, and third event, and there it is. And it did this all in one go. So of course with 3 events there's not really a real usage for the storage account, the checkpoint store. Also we don't need the delay or anything, so it did get all of them in just one go. So that's just a simple C# example. Of course libraries are available for other languages as well, and I just encourage you to try it out as usual. So enjoy trying it out. Now in this video I talked about the benefits of using Event Hubs and how it captures streaming data. We explained how to process events in code and how to perform common operations with the Event Hubs client library. In this video, you have explored Azure Event Hubs and its role in capturing events at scale. By learning how to scale your processing applications, you are equipped to handle large volumes of events with ease. With Azure Event Hubs, optimize your event processing workflows and ensure seamless data ingestion and processing in your applications. Thanks for watching. Keep on learning.